Good morning or good afternoon or evening, depending on where you are in the world today. Welcome to 24 Hours Have Passed, the Summit Preview 2018. We're excited that you could join us today for Jason Hall's session, Our Open Source Databases on Your Radar. This 24 Hours Have Passed consists of 24 consecutive live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Jonathan Stewart. I go by SQLox. I have a few introductory slides to hand over I have a few introductory slides before I hand over the reins to Jason. Next slide, Jason. Next. If you require any technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located on top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is extremely important to us, so please take a moment to complete it. This pop-up will be after the webinar ends in your web browser. Before we begin, I'd like to take a moment to thank our presenting sponsor, Quest. Quest helps IT professionals simplify administration tasks so they can focus on the evolving needs of their business. Combined with its commitment to help companies protect today's investments while planning for its future, Quest continues to deliver the most comprehensive solutions to monitor, manage, protect, and replicate database environments. The staging of 24 Hours Have Passed would not be possible without their generous support, and they are the reason this event is available to you free of charge. If you would like to learn more about Quest, and sign up for information on how they can help you, please visit the sponsors page of the 24 Hours Have Passed website. PASS is a global non-for-profit association where data professionals connect, share, and learn. Joining PASS is free and gives you access to hundreds of free hours of online content, live virtual and in-person events, and the ability to join local groups in your area, as well as the opportunity to attend the big annual conference, PASS Summit. PASS is a great way to connect with like-minded individuals, increase your technical expertise, as well as grow your career. So this 24 Hours Have Passed session is presented by Jason Hall. Jason is a solutions architect for Quest Software, focusing on database management and business intelligence solutions. Jason has worked with hundreds of customers to help architect and implement database-driven solutions, and has been a frequent presenter at various user groups and conferences. Jason is a huge baseball fan, yay, go baseball, and has visited 30 Major League Baseball stadiums in his travels. One more slide. And without further ado, here is Jason and our open source databases on your radar. Take it away, Jason.
All right, awesome. Thank you for the introduction. Really excited to be with you guys today from my home office just north of Boston, Massachusetts. I am a baseball fan, but I'm actually not a Boston Red Sox fan. So I guess a firm handshake at the PASS Summit for whoever can guess what team I am a fan of. There are some clues scattered around my office. You might be able to pick up on it. But anyway, again, I want to thank you guys for having us today. I wanted to start this session with more or less a story of a friend of mine, and any resemblance is purely coincidental. But we talk about our friend Dave, and Dave is a DBA. And Dave started with SQL Server several years ago and really became one of those kind of like accidental DBAs, right? I think a lot of us are in that boat where, you know, Dave's career started as someone who wrote reports for the business. All right, he started in Excel, eventually morphed into a higher end reporting solution, and was really tasked with building queries and building reports for his business users. And the more he got into the reports, the more he realized that, you know, where this data was being stored was pretty interesting, right? Some reports ran fast, some ran slow. You know, the filters he put on those reports would have dramatic impact on how they ran. And he started to get interested in SQL Server itself. He knew that a lot of that data was stored back in a SQL Server database. So he asked the sysadmin for access, and he offered his assistance in starting to administer those SQL servers. And he found it really interesting, right? You know, got really deep into the internals of that SQL Server, started to do query tuning, started to understand why things worked the way that they did. and kind of built this new career as a DBA. Now, at first, this was great, right? He had a handful of SQL servers, and he felt like he could really focus on the SQL servers that he was directly managing to ensure that they were of optimal health. But what happened is, kind of as Dave got really good at his job, the company started to invest more in SQL Server, right? And this whole SQL Server sprawl happened. Many of you likely lived through this in the 2000s, and it continues today, where we went from having 2 or 3 instances of SQL Server to 200 or 300 instances of SQL Server. All right, and once you're kind of at that level, you can't really focus as much as you used to on making sure SQL Server is running optimally. And his company tried to consolidate, right? Consolidation is obviously something that every customer goes through. They look for instances that they can decommission. They look for instances that are under capacity and maybe good candidates to consolidate, right? We can stack databases on an instance of SQL Server to cut down on license cost and cut down on infrastructure. But as with most companies, it seems like every one database you consolidate, 5 more pop up, right? So you can never really keep up. Your instance counts keep growing despite your best efforts to consolidate and make your environment much more efficient. And on top of this sprawl, his environment even sprawled into where his SQL servers were, right? His first SQL server was on a physical machine sitting in a data center somewhere. Virtualization is really what kind of exacerbated this whole SQL Server sprawl concept to where it really became the standard, right? Just about all of his SQL servers are currently running on VMware. And then SQL servers even started pushing into the cloud, right? Whether Azure, Amazon, Google, there's even some other cloud providers out there where they can host your infrastructure. So kind of gone were the days of Dave being able to have this small pocket of SQL servers that he really felt like he had an intimate awareness of how they were healthy, right? He could no longer do proactive query tuning. He felt like he was constantly in firefighting mode, just trying to stay afloat with the environment that he had. Right? Now, beyond SQL Server, his company even also started to explore open source technologies. Right, and this kind of started in a few different ways, right? First of all, kind of combined with this consolidation that Dave's company was going through in a general interest of cutting down on costs, right? Specifically software license costs. His customer really made Dave take a hard look at his environment his company had Dave take a hard look at his environment and try to understand, can we make use of lesser versions of SQL Server, right? This whole concept started with SQL Express, where Dave had to inventory his environment, take a look at the volumes of data, take a look at the hardware profile, take a look at the importance of those systems. And if the systems couldn't consolidate, right, and there are reasons why you can't for mainly security reasons, maybe some of those systems could make do with a free version of SQL Server. And when that didn't work, he started to explore open source technologies, right? Technologies where either have a very low license cost or in many cases, maybe even a free license cost. And there's certainly a lot of environments that are going to stay on SQL Server. Dave's company is a Microsoft shop, so SQL Server is always going to be their bread and butter, but they're starting to explore different ways to bring lower cost or even free data management platforms into the infrastructure. His company actually started small. The first use case was they started to offload some data from SQL Server to an open source platform, specifically Postgres SQL, for the use of one reporting application. Right? This was kind of a pilot to see, could open source technologies actually deliver what's needed for this specific use case? If it worked great, they might explore further. If not, maybe they just ended up continuing along their commercial path. But it did go well, right? The project went well, the business was happy. They looked at this free database server, at least from a software license perspective, that did the job, and they started to explore both for new application development and even migration of systems, how and where they could use open source technologies in their environment. So again, kind of following the path that Dave has taken in his career, right? Started as a fresh SQL Server DBA, small number of systems, really felt like he could do a bang up job managing those few systems, right? As SQL Server started piled on top of his head, right? The job got a lot harder. He could spend less time doing the things he enjoyed, right? Those proactive activities, and spent more time fighting fires, just trying to keep afloat, to where when finally open source systems came onto his plate, Dave really felt like he was in this constant mode of juggling, right? Keeping all of his projects in the air while trying to fight fires at the same time, to where he never really accomplished anything, right? Those forward-thinking initiatives that he had or the business really wanted to deliver around automation, capacity planning, maybe even that new application development never really saw the light of day. You know, Dave kind of ended up going home every night, like in this whole zombie mode, right? So burnt out, so beaten down, so basically just bummed out that he couldn't do what he had set out to do. And it really started to impact how he was not only in his business world, but also in his personal life. Okay, so this is kind of a story about Dave. I'm hoping I got some head nods from those of you out in the room that maybe are in a similar position, but we know that Dave's not alone. We did a survey at Quest with an analyst group that we partner with, DBTA, to kind of survey the broad DBA community and find out what they were going through. We had heard some stories from folks like Dave, but really wanted to quantify whether he was alone or not. And we found out he wasn't, right? This is a full survey you can get from the Quest website if you're interested. There's dozens of questions that we asked, but there's two in particular that are relevant to this topic. One is, we asked organizations over the next 3 years, what are going to be the top challenges that your DBAs are going to face? Right, and number one there is to incorporate cloud technologies. And if you actually dig deeper into cloud technologies, a lot of cloud projects actually leverage open source databases. Right, Amazon RDS, probably the biggest example of that, where Amazon can run MySQL, MariaDB, PostgreSQL, effectively open source databases into a cloud infrastructure. We also saw, if you look down here towards the bottom, 25% of our organizations say that one of their top challenges is going to be increased complexity in their database infrastructure, specifically bringing in new database platforms that have to be managed. Right, there's another bullet in here, the third one, not specifically related to open source, but kind of related, right? And that's customers that bring non-relational technologies into their environment. This presentation is about open source, but there's a segment of open source, in other words, non-relational, that involves an entirely different set of challenges, right? Where not only are we taking a SQL Server database and now having to compare and contrast it to PostgreSQL, but maybe we're bringing in something like MongoDB, right? Another open source technology that, because of its non-relational nature, kind of has to shift the entire way that we think about a server. Second question we asked, what are the reasons why you're bringing multiple databases into an environment? All right, and so kind of along the lines with what Dave went through, top reason is simply to support applications. All right, most of the database infrastructure at most organizations is vendor application driven, and you might do your hardest to try and force all of your vendors to put your data on SQL Server, and you might have been successful at that and maybe continue to be successful at that, but likely someone in the business or some application that you have to bring in is going to use an open source backend, and you're going to have to manage it. Right, you'll also see the fifth bullet down on the list says managing database licensing and support costs, right? That's huge. I'm sure every single one of you that's a DBA has gone through some sort of cost savings initiative in your organization, whether it's about capacity planning, consolidation, or in this case, exploring open source databases for their use because of the cost savings that they can achieve. So again, we know that Dave's not alone. Now, why is this hard, right? Why is Dave so stressed out about this kind of open source heterogeneous world? Well, if you look at kind of the three things that a DBA is responsible for, right? And this is overly generalizing it, don't yell at me. I know there's lots more than three, right? But to just kind of generalize, what does a DBA need to do to manage a database environment, right? The first thing I always say, step one of a DBA, make sure your database is available, right? If nobody can connect to it, what's the point? So we need to maintain and ensure availability of the database server that we're managing. Now, in addition to just simple availability, this also does include high availability, right? And SQL Server is hard enough to keep available. And there are lots of technologies that we have, replication, clustering, always on, even legacy technologies like log shipping that continue to serve us quite well. But those technologies are really important to keeping a system available. So availability management has become much more than just checking that a server's up. We also need to make sure the server's protected and highly available based on our business requirements. Right, really the second general purpose or second task that a DBA is going to have on any database server is managing the database infrastructure. Right, I understand this is a very general topic, but it's things like, how do we manage the storage that a database is allocated? How do we make sure systems are secured? How do we do maintenance on a server to make sure it's running optimally? How do we back up a system? Right, and I put the Windows versus Linux bullet in there because even inside of the SQL Server infrastructure, this has gotten a lot harder. because kind of gone are the days where we could guarantee that every SQL Server was going to run on Windows. Now that SQL Server can run in Linux and even in containers, those of us that classify ourselves as SQL Server DBAs are really going to have to broaden their understanding of infrastructure to include, Linux and container-based technologies. Right, and then really the third high-level task of a DBA, this is what a lot of DBAs love to do, but unfortunately, because they're constantly in firefighting and juggling mode, they don't feel like they have the time to do. But that's how to manage the performance of a system, right? How do we troubleshoot slow query response time? How to respond to the database is slow messages that we get from our developers or our business teams. And performance management is hard enough, but every database server is going to have its own method of managing performance, right? Where do we even get at the data, right? SQL Server's got dynamic management views, very well established, very well documented. You can generally Google whatever you're looking for, and somebody's going to have a script that's going to get you the data that you need. Well, some of these open source platforms aren't that established. Some of them don't even have a concept of a dynamic management view, or there's a different way that we have to get at performance data. So just knowing that is half the battle. And then once we have that, how do we expand that skill set into things like query stats, wait events, explain plans, and so on? So again, this gets really hard. It's hard enough in a SQL Server environment to effectively manage availability, infrastructure, and performance. And then when we start stacking additional databases on top of that, it gets even harder. Now, shouldn't monitoring help? Theoretically, yes, right? One of the ways that customers try to effectively manage their database infrastructures is by bringing in monitoring. So on paper, if you're monitoring all of your databases, then you should be able to do this job quite well. But sometimes actually monitoring makes the problem even worse, right? Part of the issue with open source is open source databases provide pretty rudimentary administration and monitoring tools, right? Basically freeware, or even the open source databases coupled with open source administration. And it's going to help with some of the basic tasks. But when you're doing deep administration and diagnostics, those free open source products just don't always deliver what you expect as a SQL Server DBA. And so you could take one route where you look at a point monitoring solution for each platform, right? Let's go find something for Postgres. Let's go find something for MySQL. Let's use maybe the native Amazon or Azure tools for our cloud-hosted systems. But then on top of learning the database platform, right, on top of you having to become an expert in the open source database, you also have to learn the tooling, right? And each set of tooling might provide its own workflows, its own way of interpreting data, its own way to get at the data, its own way to alert on the data. So now you've almost made the problem worse by first having to learn the database system, but then as you're learning the database system, having to learning how the tooling operates. You've gone from managing SQL Server to managing 4 database platforms and now 4 monitoring solutions. Now, some customers try to attack this with open source monitoring on top of open source database, and that is certainly one way to go, and I've seen customers be very successful at that. Sometimes that's even driven top down from the business, right? If we're not paying anything for the database license, then we shouldn't pay anything for the monitoring. And again, that's a perfectly valid approach. There's a lot of open source monitoring solutions out on the market that provide fairly powerful platforms that can enable you to monitor your environment. But in most cases, those platforms are just that, right? They provide the building blocks and the plumbing to drive your monitoring, but it's really up to the DBA or up to the administrator to build the scripts, build the data collections, build the alarms. So sometimes you kind of end up in feeling like you're building from scratch, even though you've brought in a monitoring solution that should have theoretically helped, right? So kind of how does Dave do it? All right, and this is kind of where we get into some product, and specifically, I don't know that I fully introduced, it was implied, I work for Quest, the sponsor of 24 Hours of Pass. We do appreciate this opportunity to show our solutions to you on top of the educational content that you're getting throughout the day. But Dave is fortunate enough to use a product called Foglight for SQL Server. All right, and Foglight provides best-of-breed SQL Server monitoring, right? Those of you that are SQL Server or database administrators, many of you might already use Foglight to manage your infrastructure. But on top of that best-of-breed SQL Server monitoring, we can also extend into open source databases to provide deep insight that you come to expect on the SQL Server side. Right, so yes, we are going to help you manage your open source systems, but on top of that, we can provide consistency in how you manage your broad database infrastructure. Right, and really provide consistent workflows for alerting, diagnosing problems, and even reporting on your findings, all in a simple unified solution. We've actually talked to DBAs like Dave, but we've talked to lots of DBAs out in the broader community who have actually told us that by using a consistent monitoring solution, they've actually been able to learn a lot about some of these newer open source platforms, right? That's actually the best way that I learn is by doing, right? I like to get hands-on. I like to see things visually. I don't like to read books and documentation. So if you have a very acute awareness of SQL Server and how to do a lot of things, and you can then translate how do I do this on SQL Server to how do I do this on PostgreSQL using a simple and consistent interface, and you'll end up learning a lot about PostgreSQL through the process. We have a lot of customers, you know, we like to pitch Foglight as a monitoring tool, but there's a lot of education and training that comes out of the product just by helping you centralize and make consistent your monitoring and diagnostics. Now, what if you aren't using open source, right? We know that there's a lot of you out there that probably are SQL Server DBAs and dedicated SQL Server DBAs, right? If you remember back to my slide about why are you managing open source or multiple database platforms, there was a percentage of the market that is not, that is still a single platform shop. And even of those that are multi-platform shops, some customers do not ask their SQL Server DBAs or their enterprise DBAs, whatever you want to call them, to manage these net new systems, right? Maybe these open source systems are kind of in their infancy. They're not under the purview of corporate IT yet. We've got a developer doing the management and administration of his application. But at some point, my guess is that most, if not all of you on the call will be tasked with managing an open source system. Right, Dave kind of put his future hat on way back when he started with Foglight to basically say, well, what if I could future-proof my monitoring, right? What if the same product that I currently use to manage SQL Server and that does a very good job managing SQL Server could also grow and evolve as my environment grows and evolves, right? So then again, even if you're not using open source systems today, if you do put your forward-thinking hats on and say, you know, what might be coming down the road in my organization, this might be a good fit for that level of future-proofing. All right, so let's get into the demo. This is my last slide, and then we're gonna get into the product itself so you can kind of see what we're talking about here. And I'm gonna take the demo in two halves. The first half of the demo is going to be specifically on Foglight for SQL Server, right? Those of you, and we know that's the majority of you folks out on this call today, are SQL Server DBAs. So we want to spend the first half really just giving you some deep dive insight into what Foglight can do for a SQL Server environment. And we'll focus less on some of the trivial commodity stuff that you just expect any monitoring product's going to have, and we'll focus more on some of the deeper functionality that we believe to be unique to Foglight. And then the second half of this demo is going to show you how, now that you're already monitoring SQL Server, you can translate and broaden that monitoring into open source systems. I listed out our current open source monitoring capabilities over on the right-hand side. So just kind of rattling through them. We've got coverage of MySQL, MariaDB, PostgreSQL, MongoDB, and Cassandra. And this list is likely to grow. So if you're watching this recording, you know, a few months, maybe even a few years from now, if it's still out there in the interwebs, just know this list is likely going to grow. We're making a significant investment in open source, and we expect to want to be able to monitor wherever our customers are asking for. Okay. So with that said, let's kind of jump into a demo. And now you'll probably, or hopefully, let me just confirm in my audience view that you can see my desktop, and perfect, it looks like you can. All right, so this is the Foglight interface. And again, I'm going to focus a little less on some of the trivial, I don't want to call it trivial, but commoditized tasks of monitoring that, again, you just expect to have, and focus in a bit more on what's unique. But before we get too deep into an individual platform, just look at this bar of instances across the top. All right, this view that we're currently looking at, this is what we call our cross-platform databases view in Foglight. These tiles that you see that I'm clicking through represent the different platforms that we support, and they also provide filtering into a specific platform. So maybe even you are a SQL DBA, SQL is your primary focus, and you don't want to be bothered with the other systems. That's perfectly fine. Click on the SQL Server tile, all the other systems filter out. Just going from left to right, though, just so you have the full perspective, we cover SQL Server. This first tile represents the relational engine. We also do have coverage of SQL Server Business Intelligence Services, and that does cover all three: reporting, integration, and analysis. We do cover Oracle, a couple different flavors of Oracle, including things like RAC, Exadata, ASM, clustering, DataGuard. We cover SAP ASE. This is a legacy Sybase platform that's been rebranded by SAP. We cover DB2 on distributed systems, mainly Linux, Unix, Windows. We cover MySQL, and this does include various distributions of MySQL, MariaDB probably being the most common, but also technologies like Percona are covered by our MySQL offering. We cover PostgreSQL, MongoDB, and finally Cassandra. All right, so again, when I talk about broad coverage of database platforms, this is really what I'm referring to here, where you can get that single pane of glass, as many customers like to call it, or that centralized view across the overall health and status of their entire database infrastructure. Now, again, I was going to kind of take the first part of this presentation to focus on kind of some of the unique capabilities for SQL Server. All right, so if I click on my SQL Server tile here, you'll see a list of SQL servers that I'm managing. And by drilling into a SQL server is really just a matter of clicking on one. And specifically, some of the unique capabilities I want to show are specifically around query performance, right? We really do think Foglight shines in the area of performance diagnostics, specifically around SQL queries. So I wanted to show you some of the things that we can do there. And much of what we do for query performance is going to be in this drill down that we call SQL PI. Right, PI stands for Performance Investigator, and Performance Investigator is a brand that we've developed to really imply and demonstrate that deep insight into query performance. Right, so anytime you hear us say PI or Performance Investigator, that's what we're talking about, diagnosing queries. Now, across all of Foglight, not just for query performance, you do have this control at the top of the screen where you can choose the time range you want to investigate. Right, we often mention real-time, short-term, and long-term analysis of data. Right, so for example, I'm right now looking at the last hour of performance, but I could very easily zoom that out, maybe over 8 hours, maybe over a full week, right, just by choosing these dynamic links in the upper right-hand corner of the console. Also, once I do have a time range specified, I can just drag that back and forth. So maybe I want to see a 4-hour window of time, but starting last night at 11 p.m. Right, maybe the query performance I'm interested in seeing was along the lines of some ETL process that was running or some scheduled report that timed out, so I can go back in time to a period in time that the issue occurred over. We can also do long-term analysis here, though, too. I won't spend a lot of time on this exercise, but by default, Foglight actually keeps data for 2 years. And that allows us to do more long-term trending type exercises as well. Maybe we've rolled this application out, it's now been running for 2 years, and we want to see a simple analysis. Is the system better or worse than it was when we initially rolled it out? Right, so you can choose long-term time ranges in here as well. You can click on the all link, or in this more drop down, you'll see reference to, this week, last week, this month, last month, right? Really giving you broad control over the time ranges that you're investigating. Right. Let's cycle back here on that 4-hour window just for the purpose of the demo. And so one really unique workflow that we have, once you have your time range selected, the process for drilling into this information is one that we call dimensional analysis. And what that means, all the entries that you see down the left-hand side of the screen here are different dimensions that we can use to break down our database infrastructure. We talked earlier that one of the first things Dave did to address server consolidation was to stack databases on top of each other. Right, and that's great for cost, from a cost perspective, right? If we can have one instance of SQL Server running 200 databases, right? I've maybe saved 199 instances of SQL, but that can make things really hard to manage the performance of a system, right? Because maybe the first question you have when you get a problem reported is, well, what database did this problem happen in? And so maybe we start there at this databases dimension, right? If I open up databases here now, I'm seeing in the list over on the left and in the grid over at the bottom of the screen, a database by database breakdown of resource utilization. All right, for example, maybe I want to sort my databases by CPU and determine what database is my top consumer of that CPU resource. So now, very quickly, right, a few seconds and a few mouse clicks, I can see my sales database is my top consumer of CPU. So now I can drill into sales. And maybe even inside of my sales database, I've got multiple users that are running queries. So maybe the next dimension I go into is the users dimension, and now I can see a user by user breakdown at the bottom of the screen, indicating what users are consuming resources on this system. Right, and then once I know that, I can keep drilling down. Eventually, you'll want to get down to the SQL query. Right, so once you go into the SQL statements dimension, we're now seeing the filtered list, and you can kind of follow this breadcrumb trail at the top here. We're looking at all the SQL statements that ran by this user against my sales database, again, keeping in mind the 4-hour time range that we're investigating. And for each of those queries, we get a detailed breakdown of performance. right? How long did the query take? How much CPU did it use? And all the various wait events that made up that query's execution time, right? So that's one thing that Foglight's really well known for, that historical analysis of query performance and being able to use these dimensions to break down resource utilization at a variety of levels. Another really powerful feature that we have for SQL Server is something that we call change tracking. And the core feature, the kind of use case here, is that Foglight is going to collect change events that are occurring to your SQL servers, overlay those change events as little bubbles here on our workload graph, so that you not only see that something changed and when, but you can visualize that change to its impact on, visually correlate that change to its impact on performance. Right, this isn't the best visual example of this, but let's say maybe at 7 a.m. this morning, we saw our workload spike, right? Spike extremely high. Maybe CPU went through the roof. Maybe some type of blocking started occurring that hadn't happened before. And right as that spike happens, we see a big dot here on our workload graph, right? Maybe we now need to look into something that changed on the server that might have caused that performance spike. The types of changes that we're tracking over on the right-hand side of the screen, and it's everything from an account change that's a change to a login or security. Maybe we add a user to a SQL server and all of a sudden our performance goes into the gutter, right? Well, maybe we need to look at what that user was doing since we didn't have this problem before that user was added. We also track a variety of configuration changes, right? Everything from a system configuration change, for example, like to the hardware profile of the server. Sometimes we see like overzealous VMware admins that think we can make do with less CPU cores or less memory. And so without even telling us, they cut our CPU core count in half, right? So you'll see that for system config changes. Master configuration changes are changes to the SQL Server instance. A lot of times these are either going to be trace flags or SP_configure changes, right? Maybe you're playing around with your parallelism settings or you're changing SQL Server's max memory allocation, right? So those things would show up at the system level. And then we have database configuration changes, right? Which are changes that happen to your databases. We also have schema changes. These are probably the things that we either want to or don't want to see as DBAs, right? People dropping indexes or modifying table schemas, creating new store procedures, modifying views, right? Anything that ends up as a DDL change will show up as an object change. And then finally, we have execution plan changes, right? And these are sometimes the trickiest to capture because they don't show up as a typical change, right? It's just we've had a query that's been running great for the last 30 days. All of a sudden, over the weekend, the execution plan of that query changed, and now the query is performing so much differently or so differently. So again, all these changes are tracked by Foglight automatically, no user intervention required. Let me just zoom out so you can kind of see a broader perspective on changes. So here you can see at roughly, what is that, about 10 p.m. last evening, a little bit before, there was a SQL Server configuration change where somebody changed my cost threshold of parallelism from 5 to 10, right? We might do this to restrict the queries that are taking advantage of parallelism, raising that floor of our cost threshold, maybe to reduce CPU utilization and make our queries more single-threaded if necessary. Right, but again, we can see that change, and because it shows up right on your workload graph, we can now visually correlate it to its impact on performance. Where we see this feature especially interesting to our customers, we think it's been interesting for years, but we're seeing an increased number of DBAs being asked to participate in DevOps. Right, DevOps is something that IT organizations are embracing as a way to more quickly and agilely respond to their users' needs by quickening and making more agile their development cycles. Right, and one of the core tenets of DevOps, right, if you look at what is DevOps, right, you're going to get a lot of different answers. But one of the things that will continuously come up is basically continuous integration, continuous deployment, making changes as they're ready to be made. Right, I've heard this referred to as break fast, fix fast, or fail fast, fix fast, where, if something's going to fail, you want it to just fail quickly so that we can fix it quickly. Right, and that's a lot easier to do if you're making changes one at a time, because if something breaks, you know exactly what change caused it, versus maybe the old days of pushing out changes once per month, but pushing out 100 of them at a time. And if something breaks, now you've got to dig in and figure out, well, which of these 100 actually caused that problem. So if you're one of those companies or DBAs who's got to manage environments that are continuously changing, sometimes even multiple times per day, change tracking can give a lot of insight into the performance impact that those changes are making. Okay. Another really nice use case I like to highlight here is something we called a comparison. Kind of fits nicely with change tracking, where maybe we want to compare performance before and after, but even also just in a more generic way of, this system was performing great yesterday. I'm getting all kinds of complaints today. Let me look at performance yesterday versus today. And you can actually do that exact task in Foglight, right? Let me take yesterday, compare it to today, and see what's different. And sometimes what actually comes out of this comparison, if you look at the use case that I went through, this is today versus yesterday, you can see the text that I've highlighted. It's kind of a bummer when I'm demoing the product because I'd like something to jump off the page, but as a DBA, this is actually what I often want to see. What that text is telling me is that Foglight compared dozens of key performance indicators for me, and we didn't find a measurable difference in any of them. In other words, for the most part, the database server did exactly what it's doing yesterday, today. Right? We didn't use any extra CPU. We didn't have a significant increase in execution counts. We didn't see any different wait event characteristics. So maybe now I can go back to the application team or the dev team or whoever made the complaint and at least have some ammunition to say, hey, I ran a comparison. Database server didn't seem to have done anything differently. If there is a difference, though, it'll be included in this list, and it'll tell you, sure enough, the database server used twice as much CPU, or the database server saw 3 times as many wait events raised, and you'll be able to quantify it. And then you can keep drilling into, for example, query by query differences, right? Maybe there's one query that took twice as long today versus yesterday. Maybe even it's a scenario where there's no low-hanging fruit, right? My CPU didn't crank from 30 to 60%, but here's one query. Yesterday was running in 2 seconds. Today is running in 10 seconds, right? And that could certainly be what's causing those complaints that you're facing. So we have these time-based comparisons. We also have a nice interface in here for instance-based comparisons. We talk to a lot of customers that have to be involved with migrations of database servers, right? Inside of SQL Server, for example, we might be migrating to a new version of SQL Server, or we might be upgrading or downgrading Enterprise Edition to Standard or Standard to Enterprise and vice versa. Maybe we're even trying to explore whether SQL Express can handle some of our workloads. Maybe we're looking at migrating some of our on-premises hosted systems into a cloud-hosted infrastructure. But the bottom line is when we do an instance-based configuration, instead of comparing 2 different time ranges, we're now comparing 2 different instances. We get our performance comparison here to see how each system is responding, right? Maybe our cloud-hosted systems using twice as much CPU or seeing some type of wait event. We also do a configuration comparison. And this is useful maybe in trying to understand why these systems are behaving the way that they are, right? Maybe we forgot to check whether our cost threshold for parallelism is the same, or we forgot to make sure that our max memory setting was set between non-prod and prod or between on-premises and cloud. So this comparison utility is a really powerful tool inside of Foglight for, deeply looking at different time ranges or different servers in order to understand any differences in performance or configuration. Okay. So those are just a couple kind of really unique capabilities I wanted to highlight, things that we do for SQL Server, right? So if any of you folks are not exploring these open source platforms today, maybe you're specifically SQL Server DBAs, certainly those might be capabilities that you might see value in and could take advantage of. But again, if I jump back to my global view, right, you can see how we can add on top of the deep dive, right, what many customers would call best-in-breed SQL Server monitoring and diagnostics, but also expand into additional platforms. And there are going to be some core, I talked about consistent workflows. There are some core capabilities of Foglight which will exist in a very consistent way across every platform that we monitor. For example, alerting and notification, right? Foglight has about 100 out-of-the-box alarms for SQL Server. We've got about 50 to 75 out-of-the-box alarms for each of our open source platforms that can indicate a potentially unhealthy system, right? And this could be alarms that are as simple as tell me when an instance of MongoDB goes down, or these can be more focused alarms, maybe about MongoDB replication or MySQL index health, or blocking and locking on a Postgres SQL instance, right? So these out-of-the-box alarms can indicate a potentially unhealthy server. Servers are going to be color-coded in Foglight based on their alarm health. So maybe we've got an environment with 100 SQL Server instances and then a handful of other Postgres, MySQL, and MongoDB instances, right? You'll be able to visually understand the health of those platforms all in the single pane of glass. right? Alarms are available visually in Foglight, but we can also set up alerting and notification on these alarms as well if you want something to end up in your inbox or maybe even be sent out to some, higher level monitoring solution. Right? We also have a really nice core capability of Foglight. Again, this will be available on every database platform that we support, called baselining. And what baselining is, let me see if I can find a better example of this. It's not a bad view. So baselining in Foglight is our ability to learn about what normal performance is. I hear a lot of DBAs ask this question, but struggle to come up with an answer, right? It's whenever you're looking at a behavior, right? Let's say you're looking at CPU that is cranked up to 80% at 8:30 in the morning on one of your 200 instances of SQL Server, right? The first question you likely want to ask is that normal, right? Does this system always use 80% CPU at 8:30 in the morning, maybe on a typical weekday? Baselining will help you answer that question, right? Foglight automatically generates these baselines. There's no user input required, but we're going to learn what normal resource utilization is per time of day, per day of week, even per monthly time range across all of your database servers, and then quickly show it to you in a variety of graphs and drill downs. For example, this server is not doing a ton of work. It's at about 20% CPU. This is actually an instance of MongoDB, but this shows us that 20% CPU utilization is perfectly normal for the system, right? That's what it usually does between 7 a.m. and 8 a.m. on a typical weekday in the, the second week of June, right? The baselines will understand each of those different time ranges. And so baselining, again, will be a core capability across every platform that Foglight supports. We can do that for SQL Server too, right? Maybe you see a SQL Server that cranks up to 90% CPU on the last day of the month, and you want to quickly understand, well, is 90% CPU usage normal for 3 p.m. on the last day of the month, right? These baseline graphs will help highlight that for us. So we talked about kind of consistent alerting and notification. We then also talk about consistent diagnostics, right? You saw how I tracked down and troubleshooted a problem on SQL Server, right? I went from the global view, I drilled into an instance to see a summary of the performance of that instance, and then I navigated into a drill down page to more deeply understand what was going on specifically around query performance, right? Well, it's a very consistent workflow to do the same sort of task on something like a Postgres SQL. All right, here's my Postgres SQL environment. Maybe I see high CPU or I see some alarm that's concerning. I can drill into a Postgres deployment. We get our overview screen showing us a high-level perspective on the health of a Postgres instance. And then I've got drill down tabs across the top of the screen, right? Maybe I specifically want to drill into query performance on my Postgres instance. Maybe, again, this is query performance during a historical time range. Let's choose a 4-hour window, but bring this back to the middle of the night. Right, and now what I'm looking at is a summary of query performance statistics on my Postgres SQL database during a 4-hour window starting at 11 p.m. last evening. Right, and I can kind of see which queries are consuming resources using some of these stacked bar graphs. I can sort resource utilization by any of the columns that we see. Maybe we're looking at response time. Maybe we're looking at various I/O metrics. And then if I drill into a query, I can continue my diagnostics. Right, look how it's trended over time. Look how it's allocating or using I/O resources. Look at its response time. Even drill into the execution plan. All right, you can see examples in Foglight how when you do see a poorly performing query, there's the option to look at the execution plan for that query right in the Foglight UI. All right. So that kind of consistency in workflow around how you diagnose all different kinds of problems is something that Foglight can deliver for you, for those of you out there that do have to manage SQL Server alongside some of these newer open source systems. Right, and that workflow exists across all of our platforms. We showed you something for Postgres SQL. It's fairly consistent for MySQL, right? Let's drill into MySQL, and then let's drill into our MySQL queries that are running on a system. Right, or even MongoDB. I can drill into MongoDB, see a high-level summary of a MongoDB deployment, and drill into MongoDB profiled operations so I can see the performance of queries that are executing against my MongoDB system. Right, so again, we talk a lot about consistency in workflow and how we manage our systems. Now, consistency is important, but we also don't want to be a product that treats every database system the same. If we did, we would overly generalize, right? And I've seen some solutions that take this approach where they want to provide the same metrics, the same dashboards, and the same drill downs across every platform that they cover. And that's good for consistency and simplicity, but that also generally means that you're not going deep enough on each individual platform, because for platforms like MongoDB, their architectures are wildly different to that of SQL Server, right? There are concepts that need to be looked at differently. So in addition to generalizing and making your workflows consistent across all systems, we also wanted to make sure we provide deep visibility into specific elements of a platform that you need to better understand. And a good example of that is if I go to my databases dashboard here and look at my MongoDB deployment, right? I've got 16 instances of MongoDB running. And this cross-platform view presents databases in a uniform way, right? And the way that we can do that is by showing each instance as its own row in this interface, right? So that if I go and look at all 41 of my database servers, I can see all of my SQL servers alongside MongoDB and look at it in that centralized, single pane of glass type view. But in reality, these 16 MongoDB instances, some of them are configured into replica sets, right? A MongoDB replica set is a way to synchronize data between different members so that we can either offload data for read-only querying or in many cases, have a high availability across a set of MongoDB servers. We can also deploy MongoDB replica sets into sharded clusters, where we've actually got data automatically split between data-bearing members so that we can scale MongoDB horizontally to support large quantities of data in a well-performing way. So for those types of visibility, we also have specific platform-specific views that look at an architecture in a way that it needs to be looked at. For example, here's our replica set view in MongoDB, where those 16 instances that you saw in the global view are actually split across 5 MongoDB replica sets. And in this case, we can see the health of our replica sets as a percentage of nodes that are available, right? 3 of my replica sets are 100% available, 2 of them have nodes that are down. And if we click into those MongoDB replica sets, we can even see the overall health of the replica set, right? In other words, where am I primary? Where am I secondary? In my case, one of my secondary members is down here, this red one, but I can still service my application because I've got a primary and I still have a failover target that I can failover to if something was to occur, right? So that's a replica set centric view, which is really important in MongoDB because one server going down doesn't necessarily mean that the database is down. It just means in the case of replica sets that maybe we're a little higher at risk for an outage. And then similarly, we have a top-down clusters view, right? Because actually, if you kind of build up the architecture here, we had 16 instances of MongoDB, but those all interact as a sharded cluster that involves MongoS query servers, involve configuration servers, and then involve shard servers, each of which is configured as a 3-node replica set. So it's really important in the MongoDB perspective to have an awareness of how each of those instances plays a role in your MongoDB cluster. Right, and in my case, my MongoS query servers are all good and green. That's good. We can connect to those. We do have issues on our config servers that actually looks like only one of them is available right now, but I do have a primary. So my config servers, I can connect to them, but I certainly am at risk there. If any of these secondaries or if this primary is going to go down, I have nothing to fail over to because they're down. And then if I look across all of my shards, 2 of my shards are perfectly fine. All 3 nodes are healthy, and you can see which role each plays. But this shard 1 here is a bit at risk. It looks like one of my members is down, but I do have a primary. I do have a secondary. So we're in okay shape, but that's certainly something I want to look at. So again, having this platform-specific awareness into the architectures that are being monitored, and in the case of MongoDB, how each member can operate inside of that cluster is extremely important. And I like to make sure I mention that. We a lot of times preach consistency and having workflows that are going to be the same or at least very similar between each database platform, but we do not do that at the sacrifice of platform-specific information that's necessary to have a deep understanding of the platforms being monitored. Okay. So that's what I wanted to cover from a demo perspective. I'll leave you with one last slide, which is where to go for more information. We do make trial copies of Foglight available to our customers that might want to kick the tires on it. So if you do want to test Foglight for SQL Server or any of the other platforms that we do support, you can head to the website listed below. And that's where you can learn more information, view screenshots, view data sheets and white papers, or probably more importantly, grab a copy of the software for yourself to check out on your own systems. And this will be left. This will be left in the meeting follow-ups as well if you're looking for more information. So with that, feel free to fire any questions away. I do see some questions loaded in already that I will certainly address. But if you have any questions that have popped, go ahead and fire them in.
Jason, the first question we have is from Arturo Cardenas. He asks, does Foglight have any plans for Couchbase, CouchDB, or DocumentDB?
Sure. Yeah, it's certainly on our radar. None of the three are imminent, but they're all platforms that we're discussing internally. We actually operate, we talked about DevOps earlier. The Foglight development has over the last few years kind of shifted itself into a more agile development model as well. So because of that, we like to be very agile, respond to customer requests as quickly as possible. So we don't like to do very long-term, 5-year out planning, because who knows where the database market's going to be in 5 years. So we have some short-term roadmap initiatives to cover commercial platforms like SAP HANA, cover some open source systems like Hadoop. When I say short-term, I'm probably talking 12 months, give or take. But long-term plans are still up in the air. I can tell you from experience, CouchDB is definitely being discussed. Couchbase is being discussed, and we've also had some plans for all kinds of DocumentDB derivatives, including Microsoft Cosmos DB. So definitely all being discussed. We want to be where our customers' data is. The reason why we attacked MySQL, Postgres, MongoDB, and Cassandra first is that's where we felt the volume of our customer base was, and we think that's been validated. But of course, we don't just want to stop there. We've actually built the UI, which is kind of interesting. One of the things we did when we built the UI of Foglight is made sure we didn't restrict ourselves to adding additional platforms. So you'll see there's some white space for us to grow here. And there's even some navigations where if I don't have the screen real estate, I can kind of page up and down to support different platforms. So you'll definitely see this list grow as our development allows for. And to your question, Arturo, the three are definitely on our list. If you want to reach out to myself, Jason Hall, I'm actually at Jason F. Hall on Twitter, or follow up with an account manager who will likely follow up with you. We can certainly put you on the list to be notified about what our roadmap plans or how those sorts of things shake out.
Okay, sounds good. And for your earlier question about where you're a fan of, it's got to be you're a Mets fan that lives in Boston.
There you go. There you go. So you notice my blueprints up above my left-hand shoulder. Yeah. So I grew up in Connecticut. I was a big Keith Hernandez fan growing up. Connecticut, we always talk is kind of like the neutral zone of New England, right? Half of us are Yankees fans, half of us are Boston fans, and then the rounding error percentage points picking another team. So I ended up picking the Mets growing up. It has not done well for me over my career as a Mets fan. Of course, they've had a few runs at it where they've been relevant, but had I picked the Yankees or had I picked the Red Sox, I would have celebrated much more than I have. But what they always say about Mets fans is they are loyal, almost to a fault. So I will continue to bang that drum as long as I'm able. But yeah, good.
Well,
good
baseball has to have baseball has to have some teams to beat. But
Hey, I like to say the Mets tease us every 7 to 8 years, and if you actually look at their trajectory, they've done it. They won it in '86. Teased us in 2000 when the Yankees blew our doors off. Teased us in 2007 when they had an epic collapse. Teased us in 2015 when the Royals beat us. So we're now in another valley, but within the next 3 to 4 years, I expect to be teased again.
We have one more question. Alexander Karkunov. I apologize if I pronounced that wrong, but he asked, is Foglight trial version only have SQL Server, Oracle, and DB2?
So yeah, good question. The trial software that I pointed you to will include SQL Server, Oracle, and DB2. We're currently internally working on packaging those other platforms into the same trial installer, but they're not quite there yet. If you install the trial version that you can download, again, you'll have SQL, Oracle, DB2. What we will do, you'll get some follow-up content, we will then allow you to download what we call cartridges that you can bolt onto that trial software. So we have to get them to you in a slightly different way. We'll give you an FTP link. If you're watching this recording 2 to 3 months from now, this will likely not be no longer be what you have to go through. But yeah, if you do want to test out MySQL, PostgreSQL, Cassandra, and MongoDB, download the installer that I pointed you to, and then reach out to who contacts you, and we'll get you access to the cartridges for those open source platforms to plug on.
Okay, sounds good. There are no more questions. So with that being said, hopefully everybody stays tuned for our next session, sneak peek, Data Storytelling 101 with Miko Yuk. That's going to be a great session. So if you guys can stay tuned, next slide there, Jason.
Yep, no problem. While I'm going to the next slide, there was another question that came in. Is the demo full featured? Absolutely. The only limitation on the demo is how long it will run for. So we don't restrict any of your capabilities or any of the features of the product. You'll definitely be able to get it a good test.
All right, so let's see here. That being said, we want to thank everyone for attending. Please stay tuned for our next session, Data Storytelling with Miko Yuk. Everyone have a great rest of your day, and thank you for joining us for our session.